Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so in today's video, we're going to be looking at a controller that Ken's controller that he sent in to us, and his auger. He wasn't sure if it had some backburn in the auger tube or what happened, but anyway, it froze up. Apparently all kinds of grief. One thing among it, he said he smelt electronics burning. And so I said, I suggested, just out of the abundance of caution, I asked him to send his controller in so we could take a look at it and make sure nothing happened to it. So anyway, let's take a look at it. It still looks pretty nice. It's not very dirty. Some of the controllers I get look pretty dirty. This one's not bad. I don't know if he cleaned it before he sent it in. So the first thing you do when you're looking for stuff like this is you give it the smell test. Ready? You go. And it doesn't really smell like burnt electronics to me. But, after the whole COVID thing, my sniffer has not really worked very well. So I can't really rely on that. But one thing that's very obvious, and you probably have seen it already too, is this fuse is fried. So we'll go ahead and pop this guy out of there. And I don't know if you guys can see that. But yeah, that's toast. So anyway, that's one thing. So I'm just going to take a look at it and under the microscope here. This camera's attached to my microscope. The conformal coating on this isn't very good. I changed conformal coating manufacturers because of this kind of result. But I don't remember seeing bubbles on it. I don't know if that's from getting hot or what. I don't know if you guys can see it. Sorry, I'm looking through the microscope. Hopefully you guys can see what I'm doing okay. What I'm looking for is so here's the auger triac right here. And what I'm looking for is signs of the trace getting too hot and melting anything. And I mean, it shouldn't, right? The fuse should protect all this, and it looks like it did its job. I don't see none of the resistors look. Well, that one looks a little bit on the brown side. I don't remember if it's supposed to look that way or not. Let's look at another one over here. Yeah, it looks like it's supposed to be that color. Sorry, these wires are in the way, aren't they? Yeah, I think it's supposed to be that color. So yeah, I don't see. So this is the triac for the auger. You can see where it says auger right here. And it has the red wire. And these are the safety caps for it. This is the optocoupler for it. Yeah, I don't see anything bad. I'm going to put some better conformal coating on it before I send it back to him. But yeah, I don't see anything. I'm just kind of looking over the rest of it right now. And I don't see anything bad. That's good. Looks like Mr. Fuse did his job. That's excellent. Yeah, those are slow blow fuses. I thought about putting fast blow fuses in them in the controller, but that's what comes in those other controllers, and that's why they have to send a spare with them because they blow out real easy, and every time you lose an igniter you blow a fuse, and that's a real pain in the butt in the middle of a cook. So losing an igniter is bad enough, but at least you can cook. You can just manually light the grill. But yeah, you lose your fuse and don't have a spare in your controller, then you're stuck. Yeah, I don't see anything on that. Looks bad. Let's look up underneath here. Let me see. Oh. Come on. Come on, autofocus. There we go. Don't see anything under there. Can't really see up there. Let's see. Is anything down there? Like I said, I don't smell anything, but that doesn't mean anything. Not anymore. So, yeah, other than just the not very good conformal coating, I don't know if it got like that over the time or what. I don't remember shipping anything like that. I will spray a new layer on there and clean it all up. That looks pretty good. I don't see anything wrong with it. Alrighty, so we have Ken's controller here on the bench. And yeah, I was going to do a quick bench test with it after replacing the fuse. So yeah, it's just real simple. I do have a chamber probe plugged into it, and I have some lights to tell me. One is auger, one is igniter, and one is fan. I think blue is fan. And yeah, let's power this guy up and see what happens. Oh. Well, good news is it powers up. That's good, which I expected, but I do see something wrong with the auger circuit. And yeah, it probably shouldn't be happening. Let's see what happens if we power this guy up. Alright, ignite fire, so it turned the fan on, turned the igniter on, and the auger is still on. Yeah, so there's something wrong there, I do believe. Let's see if it cycles off. It should cycle off in about, oh, yeah, so it doesn't cycle all the way off. It cycles off a little bit. And that kind of tells me there's probably something wrong with the triac. Those triacs are kind of like big transistors anyway. If you, it's supposed to, they're supposed to support kickback EMF, but I don't know, maybe when the auger locked up, started pulling lock rotor amps, maybe at, I mean, it was enough to blow the fuse. The fuse at 5 amps. The triac is rated for 10 amps, I believe. I'll post a picture of the data sheet when I'm editing the video, but I believe it supports 10 amps. So I doubt if it pulled too many amps and smoked it. It's probably from kickback, I guess. Maybe when it was locked up. I don't know. That's interesting. I have not seen it. I mean, these triacs are supposed to support, you know, where you don't have to put a snubber circuit in. And I went ahead and put a snubber circuit on top of it anyway, just to prevent this. And like I said, I don't really know why it did this, but it is strange that I mean, it popped the fuse, so it was definitely pulling more than 5 amps. Maybe it was enough of a spike to fry the triac, but something's definitely wrong with it. So, and I don't think it's anything else. If it was an optocoupler, it wouldn't be cycling on and off. It looks like something just got fried in the triac. And the triac, if you don't know, is the equivalent of a relay. So yeah, I'm gonna go ahead and swap out that triac, and we'll give it a shot again. Okay, so I'm gonna try to video this repair. Hopefully you'll be able to see it okay. I already had the microscope set up, so I figured, oh, why not? Yeah, so here's the triac right here for the auger. Let me zoom you guys in here real quick. All right, so first things first, let's make a little room in here. Get that guy out of the way. Yeah, so we're gonna have to remove this guy, obviously. So yeah, I'm just gonna go ahead and clip these guys. Okay, I'll take those off later. I don't know if you guys can see that okay. Alright, we'll put a little liquid flux on this guy. Alright. Well, let's see if we can heat this guy up. I got a really big tip on the end of this. I might have to throw some solder on there to help heat it up. There. Well, I wasn't, I expected that to be a lot harder. That worked out pretty good, actually. Alright. So the next thing we got to do is remove these little the pins. There we go. Alright, let me clean my tweezers. I'll be right back. Alright, got the old tweezers cleaned up. I'm going to put some flux on these pads so we can clean up the pad. I guess I should probably take that wire out first. Alrighty, that came out okay. Alright, where are we? Oh, we're going to clean up the pads, that's right. This is NTE No Clean Wick. I have no idea why it says no clean, but it's for cleaning solder. Solder off PCBs. One. There we go. Maybe it means no clean because to clean it you just clip off the dirty end. I really don't know. That's kind of weird why it says no clean. Since that's its job. Okay, let's see. Sorry, I had to move this around. So I can get to it a little better. Alrighty. And last but not least, get the old solder sucker out. I don't know if you guys can see it. I'm sure you've seen one of these things. It's not that important. It's just a, there you go, a desoldering pump. ZD-108. So I have a regular desoldering tool, but for one little hole, it's not really worth firing it up. I gotta sit there and wait for it to warm up and everything. This should be pretty quick. Oops. There we go. All right. Is that everything? Yeah, we just need to clean it up a little bit. That's what's nice about this this liquid flux I'm using, this No Clean Flux pen. It's a MG Chemicals model 836-P, I guess. Yeah, it's got a lot of, I guess, alcohol or something in it, but it does a really nice job cleaning. And then I'm going to hit it with an alcohol pad. Yeah, it does a nice job cleaning without adding a bunch of fuzz. And these alcohol pads can add some fuzz sometimes. Yeah, I need to get some, looks like there's some conformal coating right there. I don't know if you guys can see it. And yeah, okay. Get that. I know this is about as fun as watching paint dry, isn't it? There we go. That looks pretty good. Nice and flat. All right. Okay, I got this kind of set up here. Hopefully everyone will be able to see it, and my my hands won't get in the way, but you kind of get the idea. It's probably not real exciting anyway. So let's see, R2, we'll just start from the top, is right here. And when I'm editing the video, I'll go ahead and post a schematic so we can follow along. There's conformal coating on these guys. Whoops, that's not going to work. Let's see, how am I going to do this? Can you guys see? There's conformal coating on it, which is going to make this a little, oops, tricky to get in there. Hold on. Let's see, R2 right here. There we go. 100 ohms, 100.1, good. Let's see, what's our next one? R1, which is right here. There we go. 268.7. It's supposed to be 270. Okay, that looks good. All right, let's see. Next one, R3. This guy up here, he's supposed to be 47 ohms. 32.2. Whoa, that's a little bit low. Okay, I wrote that down. I'm not overly concerned, but let's check our last one here, which is R4, should be 270. There we go, 268.5. So yeah, all the resistors, I mean, like I said, usually they'll look burnt or something, you know, if they're bad. And I can't really check. These two caps are the caps in the drawing, safety caps. We know the optocoupler is okay because it was turning the it was turning the triac on and off, but the triac was you know, had some kind of voltage leaking going on. So yeah, I think it's okay. I might go check which one was it? R3. I'll test a resistor out of the pack and see what it measures using my voltmeters. Okay, I found a loose resistor in my pack. This is R3. It should be 47 ohms. Let's see if I can... 47.2, okay. Huh, well, I guess it could also be, since it's in circuit, it's giving me a kind of a weird measurement. Let me go look at the drawing. Actually, there should be another one, the equivalent for it. Let's see, which one is that? R3 is right here, so maybe, yeah, here we go, R16. I know you guys can't hardly see that. Let me measure that. This will be in circuit. We'll see what it measures. If it also measures 47, then maybe I'll just go ahead and replace R3. See, these, you have to kind of, oh yeah, 47.2. Okay, so yeah, I think I'll go ahead and replace R3 while we're at it. That might just be a little bit low. I don't know if it has anything to do with what happened, you know, from the auger, you know, a triac burning up or whatever, or getting an error, but, you know, we already have the hood open, so, you know, why not, right? Usually the easiest way to do these is to cut them. But I want to be very careful not to pull this pad up. So I'm going to try to do this. When I say cut it, you take your side cutters like this, you come down in here like that, and you go lip. Uh-oh. And then you can pull one side up at a time, but I don't know, these things are pretty tough. Well, let me change my setup so you guys can see better. I'll be back in a minute. Okay, so I went ahead and zoomed in and everything. There's R3 right there. As you can see, I broke it with my side cutter. Yeah, I have to be careful. I'll end up breaking my side cutters on those things. Yeah, those melts are pretty tough. So I'm gonna use some stuff called let's see if you guys can see it. This Chip Quick. This stuff works pretty good. I like it. So when you're doing, oops, got the wrong flux. When you're doing rework, it's real easy to pull these pads up, and that's bad, because once you pull a pad up, you're gonna have to basically pull the board out unless you can fix a pad, which doesn't happen. But what this Chip Quick stuff does is it allows you to put like a blob of this stuff over the part or over a bunch of pins like these guys right here, and it stays molten for a long time, matter of seconds, and it allows so you can do both sides at the same time. Let's see if we can get this guy off here. Oops, I don't want it on the other one. Come on. There we go. And now I got to get rid of this blob of Chip Quick. Let's see, where are you guys at? There you are. Well, darn it. I kind of got it on R2 here, so I might as well replace them both. There we go. Alrighty. See, it's still molten. There we go. Oh, sorry, you guys probably couldn't see what the hell I was doing, huh? Sorry about that. Alright, so I need an R2 and an R3, so I'll be back in a minute. Okie dokie. So, let's see here. We're going to go ahead and do R3 first. Flux on there. I probably should have done this the other way around because I am better at controlling the, let's see, can you guys see that? Probably not. I am right-handed, so it's easier for me to use the tweezers in my right hand. There we go. That looks okay. There we are. Does that look okay? Yeah. Alright, we'll go ahead and, oh, let me go get an R2. Hold on. Whoop. Let me go get an R2. I'll be right back. Alrighty. Hopefully you'll be able to see. Alright, let me inspect these guys real quick. Oh, they look okay. I got R2 a little bit crooked, but I don't want to pull it off. It's got a good solder joint on it. It'll be just fine. Well, last but not least, we have the track. Whoops. Right here. I need to put some flux on there, but you take this guy off. Let's go ahead and add some liquid flux to everything. Not cockeyed, but hold on. I'll be back. I'm gonna have to get personal with this. Hold on. Okay, I got it. I had to get my face down in there to get everything lined up. And but yeah, I got it all lined up. Now I was having problems lining this pin up because the microscope was in my way with my head, and the camera is mounted on the microscope, so I had to move it out of the way to do this. So okay, I got one pin. Probably needs a little bit more solder. Oops, you can't see what I'm looking at, can you? I got one pin soldered on, kinda. Let me get this other guy. Jeez. Yeah, this is hard to do with that microscope camera in the way there. Alright, that's that guy. That's that guy. I'm just looking. Oh, sorry, you guys probably can't see. I was just looking at that solder joint. And let's see if we can get this back tab soldered on there okay. There we go. That has a little bit of excess on there. Let me clean that up. All right. So, the last thing is I just need to solder this wire on. Yeah, if you do any kind of electrical work, you definitely have to get these wire strippers. These things are a lifesaver. There we go. Put a little flux on that baby, if I can find it. A little flux there, a little flux here. There we go. Whoops. Alrighty, and let's see, do a little wire cleanup right here. There we go. And that's ready to bench test. Okie dokie, now for the moment of truth. I got it all plugged in. Let's power this guy up, and oh, that looks much better. Good. Panel light on. You can see the ADC is working. Chamber probe outside temp is working. Hit start. Got the igniter on. Got the fan on. And there's the auger. Excellent. So yeah, I'm gonna call that good to go. I'll go ahead and test the meat probe ports, but I'm not going to do that on camera. That's pretty boring stuff. So yeah, there you have it. that is a repair. I'm not exactly sure why the triac died. I am sure why the triac died. It had something to do with the seized auger, but it should have, just blown the fuse and not the triac. It must have got a big EMF kickback or something. I'm not really sure. Like I said, it's not supposed to be susceptible to EMF kickback, and doesn't look like anything was shorted. So yeah, I don't know. Anyway, it looks good to go. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.